So the title of my talk is Heavy Metal Concentrations in Rice Crop Plants in the Vicinity of Area of Mekong River. So I have several co-authors. Most of them are present or previous students of our lab. One from Vietnam, one from Cambodia, and one from Laos. So you expect this presentation will be about those three countries. So before I start, I would like to introduce where I come from. So our university is Gwangju Institute of Science and Technology in Gwangju. So you know the Seoul. From Seoul, it is about 200 miles, but we have fast train, so it takes only 1.5 hours from Seoul to Gwangju. So this is famous for Korean traditional culture, food, and science and technology because of our institute located there. Okay. So our university is Gwangju Institute of Science and Technology. So this is a research-oriented university fully supported from Korean government. So our university is a little bit small size and very young. It's almost only 30 years old. But we are proud of the research excellency. So in QS ranking from the UK, there are many factors. Only one important quantitative factor for the university ranking is citation per faculty. Our university is number 4 in the world for the citation of faculty. So that is number 1 in Korea for more than 10 years. So our university is small, but very strong for the research excellency. So now I will start my research topic. So actually I came here 2018 for this meeting, but after 4 years, I'm getting old. Now I need glass. Okay. Okay. So we should talk about the rice. Before we start, in the global nutrition, so here you can see the average daily consumption of food. Here you can see the rice is very important in Asia. Wheat and other products are important in the other continent. So you can see 42% of our daily energy supply come from cereal crops, including rice, wheat, and maize here. And let's see the sharing of global rice production. Here you can see almost 90% is produced in Asia. Also, lots of rice are consumed by Asian people. And here you can see the rice consumption in each country. So gold medalist is Bangladesh. Cambodia is silver. Laos is gold. What is? Okay, no, the copper one, a bronze medal. Then here we can see the Cambodia, Laos, and Vietnam. So Cambodia consumes 245 kilograms per capita per year. In Vietnam, it's a lot, more than 200. So rice is really important crop plants for the people in Mekong River region. Then I should also touch the story about arsenic. So let's go to this slide first. Why arsenic is important in this Mekong River area? This slide is from 2005 from the airplane when I landed on Siem Reap in Cambodia. You know the famous big lake, Tonle Sap Lake. But as you can see, this is heavily contaminated. Surface water, lake water is heavily contaminated. So international organization like UNICEF developed the groundwater because groundwater is safe. But unfortunately, this groundwater is contaminated with arsenic. But contamination is not the proper word. Enrichment, because arsenic is naturally enriched during the formation of aquifer. That's why this is not the point source, non-point source. The arsenic-enriched groundwater are distributed in lots of area. So Cambodian government paint the red when arsenic is higher than WHO standard. If it is lower than 50 at the time, they paint the green. So let's go back to the slide. Like the story, there are many arsenic contamination enrichment in groundwater near the Mekong River. We did lots of survey in many places. For example, we did survey in the lower Mekong Delta region, including Anjang, Tongthap province. So arsenic concentration in groundwater, the permissible level is 10 ppb. Here in Anjang province, arsenic is more than 1,000. This is really high concentration. So during the survey in Cambodia, we met many skin cancer patients. This is from the groundwater pathway. But when they use the groundwater for the rice and some other food pathway, they contribute this arsenic accumulation in body. So that's why we should start this survey. Okay. So arsenic is king of poison because this is a US EPA, the group A chemicals. Also, this is a carcinogen. This is related with the cancer. And also in Korea, arsenic is called as a poison of king. In our old history, when king changes his mind for his wife, he's chasing another lady, they use this arsenic. So we use that. That's why arsenic is poison of king. Then arsenic speciation, arsenic 3 is the most toxic chemical form of arsenic. This arsenic is widely distributed all around the world. The main case study is about the naturally enriched arsenic in groundwater, like Vietnam, Cambodia, Laos. And another source of arsenic is mining activity. So arsenic is geochemically very close friend of gold. After we extract the gold, the remaining rock particle, arsenic is really high. So we call them as tailings. So when it rains, this tailing is transported to the river system. When we use this river water for paddy rice, so arsenic is accumulated in the plants. So you are only old generation are familiar with this slide. Nowadays, younger generation does not know this Korean drama, famous Korean drama 대장금. Okay, in 15th century, the king Jungjong suddenly lost his eyesight, and he has got skin hyperpigmentation. So those are the medical doctor for the king, but they are useless men. Okay, they don't know why. But she is the chef, 대장금. You have many Korean restaurants named 대장금 in following her name. So she found the pathway. And this is the story. King used to go to hot spring, but this hot spring is enriched with arsenic. But that is not main pathway. king used to drink milk. In our old history, milk is very rare. Only the king can drink milk. But this milk was produced from arsenic contaminated area. So arsenic is enriched in the soil. Then when they have grass from the soil, arsenic is transported to the grass. When cow consume this grass, arsenic is accumulated in its body. When it produces milk, arsenic is enriched. This is the main pathway. First case study of arsenic toxic patient in Korean history. So this arsenic is also very important in rice. Here you can see arsenic exists in the parent rock, moved to soil, and arsenic is accumulated in the rice. So when we consume this rice, arsenic can be accumulated. We have many symptoms here from this overdose. The typical symptom is skin hyperpigmentation and skin cancer. So here you can see many cases here. So before we start this project, we did lots of survey for the arsenic in rice in many countries and in many cases. And this is a part of our review paper. So here the case in Vietnam and Korea, we have high arsenic in rice from the metal mining area. In Vietnam, we have some case study in this province. Sorry, I cannot pronounce quite well. So in Thailand, in Vietnam, they have arsenic contamination in rice, mainly from the mining site. Then when they have a high arsenic in tailing, it can be transported through the ecosystem, then arsenic can be accumulated in the human body. So this is the study from our lab. So here the province is Kanto, yeah, and other area we have high arsenic in rice. Beginning in 2008, residents of Anpu and Putan district have been using alternative source of drinking water because the groundwater is contaminated. After that, arsenic in rice can be the main pathway of arsenic accumulation in human body. And this is a case study from other paper. So from that, 24% of Mekong rice samples exceed the permissible maximum concentration, and 10% contain more than twice as much. And cadmium concentration is a little bit reasonable, not too high. And the permissible maximum concentration, total arsenic for adult and young children are these numbers. But for 37% of young children in that area have got arsenic accumulation in their body. Then this is our case study in Cambodia. So we surveyed many areas as a recurrent survey. Then finally, we have this result. So you should remember the third one, this Kandal province. So the arsenic concentration in rice in Kandal province is much higher than other area. Even mercury is really high. So here you can see total arsenic concentration in croplands. In addition to rice, you can see high level of arsenic in Kandal province, especially morning glory is a hyperaccumulator of arsenic. Another hyperaccumulator of arsenic is Chinese brake fern. Okay? Then we continue this survey in this Cambodia. This is project with my previous colleague, Dr. Kong Ki Fan in Cambodia. Then we did field survey for the rice and croplands. In addition, we collect the biological sample. We collect the human hair, fingernail, toenail, and blood and urine sample. Then we can see the accumulation of arsenic in their body. Okay, So this is the arsenic result in groundwater. You can see high level of arsenic in the high pH and in reducing condition. One thing I want to emphasize is the arsenic chemical form speciation of in groundwater in Kandal province. I mentioned that arsenic 3 is the most toxic form. Unfortunately, dominant arsenic form in this groundwater is arsenic 3. That this is the most toxic form. Then we did the risk analysis using EPA model. So we add all the data about human body and diet and everything. From that, here you can see the hazard coefficient value in Kandal province is much bigger than other area. And from the cancer risk is also high in the Kandal province. So there are one main pathway is the groundwater, but second main pathway is food pathway. Then we compare the arsenic concentration in groundwater and average daily dose. So we conclude that they have very strong positive correlation. It means that groundwater, arsenic in groundwater is the main source of the arsenic accumulation in the body. And we follow up other food stuff for the arsenic. And from this result, you can see that arsenic level in paddy soil in Kandal province is much higher. Also, the arsenic in paddy rice is also much higher in Kandal province. Then here you can see positive correlation. If arsenic is high in soil, the rice from the soil contain high amount of arsenic. Then when we compare the other food stuff, we are sure that the Kandal province, they have high arsenic in other food stuff. Then in following this survey, we did the human health survey to see whether they are arsenic-cosis patient or not. Then we want to see the difference of arsenic accumulation in the body. So this is the patient, arsenic-cosis patient during the survey. Time is limited, so I should speed up. So in conclusion, we can see that arsenic concentration in blood is higher in the arsenic-cosis patient than those in non-patient. So the red one is arsenic-cosis patient. Then in summary, arsenic in rice is an additional source which is attributed to the high arsenic accumulation in the resident bodies in Mekong River Basin, Cambodia. So this result was fully reported in the newspaper, and many local people realized that arsenic in Kandal rice is really important issue. So we should find out how to reduce this contamination. Actually, I'm environmental geochemist. My final objective is for the remediation of this arsenic contaminated soil and groundwater. So in the final topic, I will talk about the preliminary survey result in Laos. Here we add one more the interesting topic, climate change. So we want to see how climate change give any influence on arsenic redistribution in the ecosystem. So for example, if temperature increase, you can see increased heat-related mortality and waterborne disease. So after we have flooding or some kind of natural disaster, the drinking water is not safe. So we can see many cases of waterborne disease. For example, in Fiji, after tropical cyclone Winston, some area typhoid patients were rapidly increased. So we provide safe drinking water. And there are many natural disasters, and coastal ecosystem is destroyed, and rising sea levels. I know that in some part of Vietnam, you have seawater intrusion, so they may damage their agricultural activities, everything. This is related with climate change. So the climate change can affect both surface and groundwater quality. It can particularly affect the diffuse of non-point source of pollution. It means that after flooding, for example, there is one mining site in the mountain. During the flooding, the tailings can be transported to the river system. So this is a redistribution of contaminant from the climate change. And climate change could release heavy metals at some enhanced rate from the peatland, wetlands. So we have many case studies of the very strong impact of redistribution of heavy metal and arsenic after the natural disaster, including flooding. So this is a story about Laos, so I can skip that. So major disaster and climate change in Laos is very vulnerable country from the climate change. When you see the case in flooding, this is the blue one, and 1980, this is the number of people are damaged, but in 2020, it has been increased almost double. This is from the climate change. And this is a hazard risk index in Laos, especially southern part of Laos, near Atapu or Pakse area. They have strong damage from this climate change. So in 2018, there was a dam collapse in Atapu. Unluckily, Korean construction company is related with this dam construction. So after this dam is collapsed from the flooding, many people should move to the temporary place for living. But they drink the groundwater in the refugee camp, but this groundwater is contaminated with arsenic. So this is a photo from that period. Then why Laos is vulnerable? This is related with the human nutrition status and many factors. But anyway, here you can see the figure is about the vulnerability for the climate change. Laos is easily damaged country. And adaptation value is very low. It means that Laos is easily damaged from this climate change. Then the effect of climate change to agriculture in Laos is the great majority of Laos farmers are engaged in rice agriculture. And Laos per capita rice consumption is really high. Then by 2024, the production of rice yield will be decreased up to 20% from this rice. However, the rice production threatened by this stress of climate change. Then, so we have some sample from this rice. This is a preliminary result. So we collect the rice sample in the Atapu area. We collect the rice, soil, surface water, and groundwater in this spot. And this is photo during the survey. Then heavy metal concentration in some sample is high, especially in R11 and 12. The arsenic is really high in rice grain. And that is the targeted at the most relevant contaminant in flooded rice paddy is arsenic. And arsenic concentration rice sample from low catchment area of Atapu. Then we also measured our other parameters in groundwater. Then this is arsenic and barium concentration in groundwater. Here you can see some sample is much higher than WHO standard for arsenic. And that's my final slide. Okay, thank you for your attention. Thank you. Xin cảm ơn.